We're starting a brand new section today called 3.1 Algebraic Expressions. There's quite a few terms that I want to teach you today, so go ahead and write these down in your notes. The first word I want to talk to you about today is terms, okay? These are the parts of the expression that are being added or subtracted together. For example, I've given you some here: an x, a 4x, an 8, a negative 10, a 3x, and an x squared. Okay, so all of those are examples of terms because they're things that we might see in math that we could add or we could subtract together. Next up, a variable term. Read to me what a variable term is.
A term with a variable in it.
Okay, a term with a variable in it. Do you guys know what a variable is? What is it?
A number with the letter in it.
A variable is a letter. So it could be any letter of the alphabet. What are the two we see most in math? X and Y. Okay, but it could be anything. Anything that has a variable or a letter in it. So notice, this has a letter in it. 4x has a letter in it. X squared has a letter in it. Okay, so all of those are examples right there of variable terms because it's a term that has a variable or a letter in it. Next up, coefficient. This is a tricky word. Everyone say coefficient. Coefficient. All right, it's not a word that we normally talk about, but a coefficient is the number part of a variable term. So basically, it means the number that is attached to a letter. Looking at this, what is the number that's attached to 1x? 1. What is the number that's attached to 4x? 4. What's the number that's attached to 3? 3. Okay, so now looking at 5x squared, what is the coefficient, or what is the number that's attached to 5x squared? 5. What's the number that's attached to 8x squared? 8. So the coefficient is the number part of the variable term. Next up is a constant. Read to me what a constant is. A number that stands alone. So if you look at this right here, and this were to say 5x plus 3, which one of those numbers is standing by itself, not attached to anything else? The 3, okay? So right here, this 3 is my constant because it's a number that stood by itself or it stood alone. Next up, like terms. These are terms with the same variable that is raised to the same power. Now remember, a power is when it has an exponent or a little number there that's attached. I want you to pull out your red pen. We're going to just go ahead now and we are going to circle the first 3 terms that we see here. 2x squared, 4x squared, and 3x squared. The reason why I'm circling those is because those are like terms. They are all in the x squared family. They just have different coefficients or different numbers that are attached to them. Next up, you can see in blue, I want you to underline this with your red pen. 5 and 6. Those are numbers that are standing by themselves. What's the new vocab word that we learned that is a number that stands alone? Constant. A constant. So those two are like terms because they're both constants. Next up, I want you to circle the 8x and the 10x. If I was to say they were a part of the family, they would be in the x family. Now, can you tell me why the x family is not in this family over there? What do you think, Charbel?
Because that is an x squared.
You are correct. That's the x squared family. So while they might be cousins, they are not in the same exact family. So you look just carefully at whatever the variable term is, and you look at the variable to see which family that they are in. One last thing that I want to talk about is simplest form. When you put something in simplest form, that means there's no more like terms, and we'll talk about that today. The first thing this asks us to do is to identify the terms and the like terms in the expression. Here in red, this should not be a new statement. We've memorized this. We learned this in our first chapter. So you've got to remember, this is super important in today's lesson. Every number has a sign, and that sign is directly in front of that number. All right, say that statement with me because this is super important. Here we go. Every number has a sign, and that sign is directly in front of that number. Excellent. That's going to help us as we work through problem A. So as we're working through this, we're going to talk about the terms, okay? The first term that you see there, it's a part of the expression being added together, is 9x, okay? Do you see anything else that is in the x family in my original problem right here?
The x.
The x, okay? Now, guys, how many x's are right here? 1. So you could put an imaginary little 1 there because that means 1x. Now, remember, every number has a sign, and that sign is directly in front of that number. So what is this? It's not just a 1x, it is negative 1x. Everybody underline negative 1x. Is there anything else in my original problem that's in the x family? No. There are some constants, some numbers that stand alone. What's the first number that stands alone? Not a 7. Not the 2. What's it called? A negative 2. Okay, remember, every number has a sign. So we're going to go ahead and circle that. I'm not going to underline it because it's not in the same family as the ones I've underlined. But is there anything else that's in the negative 2 family?
No.
The 7, because it's also a constant. It's a number that stands alone. So we've got the x family, and then we have the constant family. So now what it's asking us is to come up with what the terms are. Remember, a term is a number that's added or subtracted together. The first thing is a 9x. So let's go ahead and write down 9x. Then we're going to put a comma because we're going to separate it. As you can see, the next term that's there is a negative 2. Remember, these are just the numbers or the variable terms that are being added together. What's the next term you see there, class? A positive 7. Now, you don't have to put the plus because we know that when it looks like that, a 7, that means plus 7. What's the final term you see there?
Negative x.
Negative x or negative 1x. You can write the 1 if it helps you, but you do not have to. So those are the terms. Those are the different part of our original problem that are being added together. Now, I want to do something different. I want to find the like terms. Everybody go ahead and look at your notes that we just wrote and read me the definition of like terms. Go ahead. Terms with the same variable that is raised to the same power. So let's look at our very first term we have up here, 9x. Is there anything else that's a term that's like that, that's in the x family? Nehemiah? You are correct. So we're going to write this 9x and negative 1x. Those are the only terms that are in the x family. So those are the only two that are alike each other. Is there anything else that you would say in my original problem that was like another number that was in there? Charbel?
Negative 2 and negative 2 and 7.
You are correct. Negative 2 and 7. The reason why those are alike, you guys might look at it and be like, no, one's a positive, one's a negative. But they're both constants. They're both the numbers that are standing by themselves. That means that they're alike because they're numbers that stand alone. Let's move on to the coefficients. Once again, these are new vocab words, so I want you to look at our vocab words we just wrote down and read to me what a coefficient is. The number part of a variable term. Now remember, a variable term is anything that has a letter in it. So do you see anything in our original problem that had a letter?
Yes.
Which one?
X.
Okay, 9x. Was there a number that's attached to that x?
Yes.
What is it? 9. So the coefficient is just plain old 9. You don't want to put the x because a coefficient says it's only the number part of the variable term. Were there any other variables there that had a number attached to it? What was it?
Negative 1.
A negative 1. Thank you for remembering that negative is right there in front of it. Are there any other coefficients? Are there any other numbers that are attached to a letter or a variable? No. So I'm now done with my coefficients. Let's move on to the next one. Brody, what is a constant? You can look at your definition if you don't remember.
Is a number that stands alone.
A number that stands alone. Did we have any constants or any numbers that stood alone in our original problem, class?
Yes.
Yes. What are my constants?
Negative 2 and positive 7.
Negative 2 and positive 7. Now, when we say it stands alone, it doesn't mean it's over here all by itself. It means that it's not attached to a variable. It's just a number that's in our problem that's not attached to a variable. So that is the 4 things that we're looking for as we're identifying terms and like terms in the expression. Let's do another example just to see if we can kind of get the hang of this. Let's first off underline, this is my x family. Is there anything else in the x family?
Yes.
What is it?
5x.
What kind of 5x?
Negative.
Negative. Thank you for remembering the negative. Is there anything else in the x family?
No.
No. What other kind of family do you see there?
Constant.
The constant family. Javaria, who's in the constant family?
The positive 7 and the positive 10.
You are correct. Thank you for attaching the positive to it. So now we're going to go ahead and start our problem. First of all, the terms. Remember, the terms are just the different parts that we have in our original problem. The first term we see, girls, is what?
Negative 3x.
Negative 3x. Now we're just going to read from left to right. Boys, what's the next term that we see there? Positive 7. You could just write it as a 7. Girls, what's the next one? 10. And boys, the final one? Thank you for telling me negative 5x. Good job. So those are the terms. They're the different parts of our expression. Going on to the next one. Like terms. Remember, these are people or numbers or variables that are in the same family because they're alike. The first one I'm going to do, let's go ahead and start with this right here. Negative 3x. Was there anything else that was like terms with that? There you go. So we'll start with that one first. Negative 3x and negative 5x. Sierra, do you see anything else here that has like terms with each other? Very good job. The 7 and 10. They are alike because they're both numbers that stand by themselves that aren't attached to a variable. Are there any other like terms in my problem, guys? No. So we're done with the like terms part. Next, I'm asking you to find the coefficient. Remember, the coefficient is the number part of the variable term. Okay? So remember, a variable term is a letter. So look at any of the letters and see if there are numbers that are right next to it that are attached to it. Who can help me with what my coefficients are? What do you think, William?
I think positive 7, positive 10.
Okay, remember, a coefficient is attached right next door to a variable. It's the number part of the variable term.
Negative 3.
Negative 3, good job, because it's attached to the x. And what else?
Negative 5.
And negative 5, because that's also attached. But notice he did not tell me to put the x there, because the coefficient is only the number part of the variable term. All right, and the last one, a constant. Guys, what is a constant? A number that stands alone, okay? The one number that's not attached to anything else. Brody, what are my constants?
7 and 10.
7 and 10 is correct. You guys kind of understanding how to find those different things?
Yeah.
All right, let's go on to the next one. This one looks similar, but it also looks a little different. What looks different about problem C from A and B? Javaria.
There is no x.
Okay, there's no x's. Taylor? There's y's instead.
It's exponents.
There are exponents also, okay? So the first thing here you can see is y squared. How many y squareds do I have?
2. 1.
There's only one, so I'm going to go ahead and just slip in that y squared right there is this. That means that one is a y squared. Do you see anything else in the y squared family?
Yes.
Which one?
The 3y squared.
The negative 3y squared. Good job. Are there any other y squared for it to go into that?
No.
No. What do you see different now?
The family.
Just plain old y, okay? This is a totally different family. So we've got 5y. Is that positive or negative?
Positive.
That is positive. Is anybody else in the y family?
Yes.
Who?
The 5y.
Wait, what? Just the y.
Just the plain old y. How many y's are right here? 1. So you can slip in a little 1 because that means 1y. Okay? So we've got two families or two like terms here. The y squared term and the y term. You cannot mush those two together. No matter how much you want to, those are two separate families, so you have to keep them separate from each other. Okay? First up, Haley, what's the first term that we had in our original problem? Very good. The first one was y squared. Taylor, what's the next term? Very good. 5y. Alexis, what's my next term? Negative 3y squared. Harmony, what's my last term? Very good. 1y. Now we're going to find our like terms. Madison, what's the first like terms that you can see up there in our original problem? Remember, that means if you're looking for like terms, they're in the same family. Okay, so y squared, and what is like with it? What else is in the y squared family? Negative 3y squared. Very good job. Nikki, is there anything else that I have that's like terms in my original problem? Very good. Okay, so I'm just going to put a comma to separate it. 5y and the 1y. Those are a part of the y family. So they are like terms. Cameron, the coefficient. Remember, the coefficient is the number part of the variable term. So it is a number that is attached to some kind of a letter. What's the first number you see that's attached to a letter?
Y squared.
Okay, y squared. What number is attached to that? The 1. So we're just going to write the 1. Are there any other coefficients in my original problem? Read from left to right. Okay, we just dealt with this first one, the 1y squared. What about the next one? Is there a number that's attached to that second term? A 5. Okay, so my next coefficient is a 5. What about the next term? Is there any number that's attached to the variable? Negative 3, very good. And what about the last one? Are there any numbers attached to the variable? 1, okay? Now notice I have a 1 here at the beginning and a 1 here at the end. You do not have to rewrite that there's a 1, or you can if you want to. It does not matter to me. Let's look at the last part. We're looking for constants. Remind me again, guys, what is a constant? A number that stands alone. That means the number that's not attached to any other variables. What are my constants here? There are none. So all you're going to do, you don't have to make up that there's any. You just simply write none because there are none. All right, next instructions have asked us to simplify the expression. In red, I hope you've written this part down. All that means is you've got to combine the like terms. So you're going to add or subtract them together. And that just means to add the coefficients or add the constants. So let's work through problem A to start with. 6n minus 10n plus 4. Is there anything that is alike to the 6n? Anything that's a like term?
10n.
Okay, not 10n, but
6n.
negative 10n. Because just remember, every number has a sign, and that sign is directly in front of the number. So let's go ahead and underline this. They are a part of what family, guys?
The n family.
The n family. Now we've got a 4. Is the 4 like terms with anything else? No, it's the only thing that's just standing by itself. So that means I don't have to combine that until the very end. So now let's look at this right here. Do I have the same sign or different sign there, guys?
Different sign.
Different sign. Tell me the rules. Same sign, add and keep, different sign, subtract and take. Since these are different signs, I have to subtract the numbers. What is 10 minus 6? 4, and then take the sign of the larger number, which was 10, and that's a negative. So this is negative 4. Now, what family was that in? The n family. So if I have 6n minus 10n, my answer is negative 4n. Now, this little guy was all alone by itself, so all I'm going to do is just drop him down. Now, let me tell you, I cannot combine those. Why can I not combine those? They are two separate families. They're not like terms. So that's it. When you simplify, it doesn't mean to solve. It makes it more simple. So I was able to combine two terms and make it smaller. Now notice, something I want to see is, I would love to see the variable or the letter come first, and then I like to see the constant come there at the end. Okay? Let's go on to the next one and see if we can combine like terms here. The first one is negative 8y. Alexis, is there any other like terms with negative 8y? Is there anything else in the y family? 6y, anything else? The y that's all by itself, how many y's is that?
1.
That's just one y. So once again, you can put that coefficient in there because there's an understood 1. Are there any other y's that I need to underline?
No.
No. Haley, do you see any constants, any numbers that stand alone or that are not attached to a variable? Which ones do you see? Okay, plus 4 and plus 2. Remember, you always want to attach that sign with it. Now, if you look back, it tells me here I am combining like terms, so I'm going to add the coefficients or the constants together. We always want to do the variable part first, so let's see if we can combine these together first. Let's do the first two numbers. negative 8y plus 6y. Same sign or different sign, guys? Different sign, subtract and take. So what would that be right there? Okay, take the sign of the larger number, negative 2y. So we just did this one, and those equal negative 2y. But I still have to add one more y. What is negative 2y plus 1y? Same sign or different sign? Different sign, so subtract the numbers and take the sign of the larger number. Okay, very good job. Negative 1y. Am I done? No, there's still something else I have to combine. What do I still need to combine?
4 and 2.
The 4 and 2. Guys, what's 4 plus 2? Okay, so you're going to put down plus 6. And you have now simplified or made it more simple what our expression was to start with. Next up, first one is the X family. Is anything else in the X family, guys?
Yes.
What else? Everything else, the 8x and the 4x. Now, I taught you a rule once that said a number and its opposite always equals 0. So if I have negative 5 plus 5, that's 0. Negative 10 plus 10, that's 0. Does anyone see opposite terms in problem C? Taylor, what are they?
Negative 4x and 4x.
Guess what happens to negative 4x and 4x? They become a 0. Listen, you could just go like this, and what's left, guys? 8x.
0.
All right?
8x.
Looking for opposites. That's one of those shortcuts that can make your problem super simple. Next up, is there anything else in my W family?
Yeah.
What else?
Everything else.
Everything else. 5.2W, and how many W's is that last one? 1. Let's just put it in there. The coefficient, because it's the number part. Now, this right here, I would say on the right-hand side, I could probably do this math in my head. What's 5.2 plus 1? 6.2. Please do not say that it's 5.3, because look, 5.2 means 1.0 is what we're adding together, which is 6.2, okay? So I'm going to do that. Remember, my commutative property says it doesn't matter what order I am adding in. So I'm going to bring this down right here, and I have 6.2W for this section. Then you have to bring down your plus sign, and you have to bring down your negative sign. Here we have, guys, a negative and a positive. Same sign or different sign? Different sign. So we're going to subtract and take. Let's take the biggest number, 8.5, and subtract the smallest number. What's the answer, guys? Okay, because the negative was bigger, it's negative 2.3 W. And there is nothing else to combine, so I have simplified problem D as much as I could have. A lot of times when people see something like this, they get scared because they see a fraction. Let's still do it like normal. What's the first family that you see there, guys?
B.
The B family, all right? There simply just happens to be a fraction with it. Is there anything else in the B family?
No. Yes.
Yes, what else?
The other B.
The other B, negative 3/4 B. Now, we're just going to do this like normal. 3/8 minus 3/4. Do I need a common denominator?
Yes.
What is it?
8.
8. Okay, so this is going to stay the same. 3/8. How do I get from a 4 to an 8?
2.
Multiply by 2, which means this has to multiply by 2. 6. Now, when I think about this, this is a positive, this is a negative, because I'm subtracting. Is that the same sign or different sign? Different sign, subtract and take. So what's 6/8 minus 3/8?
Negative 3/8.
3/8, and then take the sign of the larger number, which was negative. Was this a part of any family?
Yes. B.
The B family. So make sure you keep that B. The answer was negative 3/8 B. One more example like this. Let's underline anything that's alike. The first term says negative 10y. Is there anything that's like terms with negative 10y?
Yes.
What is it?
Negative 5.
Negative 5y. Is there anything else that's like terms with 15x?
No.
No, so we're going to leave that alone. Let's only combine like terms. Let's combine the things we've underlined. Negative 10y and negative 5y. Is that the same sign or different sign? Same sign. Add the numbers. Keep the sign. Negative 15y. Am I done?
No.
What do I have to bring down? This was still left there, so let's bring down plus 15x. Can I combine those two?
No.
Why not?
X and Y are different.
They're in two totally different families. They're not like terms, so that is as simplified as it can get. All right, so here's a review. We're going to underline a 7. Who else is in the 7's family? The negative 5. Anything else that's a constant?
Yes.
There's no other constants, no other numbers that stand by themselves. Are there any other like terms in there?
Yes.
What else?
B and 3 over 4.
Okay, 3/4 p. Who else? 1p. Who else?
2x. No.
No, the 2x is not with anyone. So let's go ahead and write our terms down. The first term, just the boys, was a 7. Boys, what's the next term? No, the next term that we're adding together from left to right. 3/4 p. Sierra, what's the next term? All right, very good. We've got negative 5, and then we've got p. You can put 1p if you want. And boys, what's the final term?
2x.
2x. Now I want you guys to go ahead on your own and write down the ones that are alike. We've underlined and circled them already at the top. All right, as I walked around, a lot of people found the like terms. The first ones were 7 and negative 5 because they're both constants. And the next was 3p and just plain old p because they're a part of the p family. And here's one thing I saw some people, 2x. Is there anything like the 2x?
No.
No, so please do not tell me it's a like term. It's all by itself, so we do not put that as a like term because there's nothing else that's like it. Okay? There's one last one for you to do on your own, problem number 2. Final problem of the day. Always make sure you're underlining and circling. So here we have 8 when I combine these two together. And then when I combine these two, I've got 11p. Now listen, is my correct answer 19p?
No.
Why not?
Because it's
You cannot add them together. Now, let me teach you something I am looking for. I always want the variable to be first. So I'm just going to switch the order. 11p plus 8. And that is your final answer. Tonight's homework is page 95. There are just 10 problems. Good job listening today.